Alright, hello geometry. We are doing lesson 4. We're going to talk about medians and centroid. So the centroid is the point where all three medians of a triangle intersect. And a median is a segment connecting a vertex of a triangle to the midpoint of an opposite side. So we'll use GeoGebra to take a look at this. So if I take my GeoGebra app and I draw any type of triangle, again, doesn't matter what type of triangle I draw, I'm gonna go ahead and I'm going to find the midpoint of the line. So I'm gonna find the midpoint of A and B, that's gonna be point D. The midpoint of B and C, that's gonna be point E, and the midpoint of AC, that's gonna be F. Now I can create lines. Again, it's the midpoint to the opposite vertex. There's one, midpoint, opposite vertex, midpoint, opposite vertex. You can see that they all intersect at one spot, and when we take the medians to the opposite vertex, that's called the centroid. So we're gonna make this point G is our centroid. So if there's a special kind of relationship or value with the centroid, is that it creates these medians, okay, and it splits them up into distances that are 2/3 and 1/3 of the whole line. So if I look at A to G here, it's your distance, there we go. A to G is 4.9, but A to E is 7.4. So again, it's going to be rounded a little bit, but 4.9 is 2/3 of 7.4, which again means GE is going to be only 1/3, which is 2.5. So again, a little bit of rounding errors, but 2.5 plus 2.5 gives us 5, and then 5 plus 2.5 gives us 7.5. So again, just because I drew this kind of up, we have slightly different numbers because of rounding, but we could check that on all of them. So maybe we get rid of those. Let's do the same thing with a different line. We can see that C to D all the way is 6.9, which is about 7, which means DG is going to be 1/3 of that, which is 2.3, and GC is going to be 2/3 of 6.9, which is 4.6. So if you notice on this one, I could take DG times it by 2, and that would give me GC. 2.3 times 2 equals 4.6. So if we jump back to our notes, again, that's kind of showing right here where my segment, my big segment, is 3/3 or 1/3. And then my smaller segment is going to be 2/3. So AP is 2/3 of the entire thing. And then that leaves 1/3 as well. So again, this is 2/3. Oh. This is 1/3, and then the whole thing is going to equal 3/3. And that's going to be true for all of them. So BP is equal to 2/3 BF, CP equals 2/3 CD. And again, point P is the centroid. So if we look at this, so in triangle RST, Q is the centroid. So as soon as I find out that this is the centroid, I know things. And it tells me that SQ is 8. So again, SQ is 8, which is my 2/3 section. So from S to W, that's 3/3. Okay, that's the whole thing. And then this small section that's given to me from S to Q is 2/3, which means Q to W is just 1/3. So if my 2/3 section is 8 and I only want 1/3, that means I have to divide it by 2. I have to cut it in half. So 8 divided by 2 gives me 4. So QW equals 4. And then SW, again, you've heard me say this before, little plus little equals big. I take my little segment SQ, I take my little segment QF, and it's going to equal 12. So using what we know, we can kind of substitute some things in and figure out what we don't know. Now if RQ, so I'm gonna, let's see here, just gonna kind of move this stuff out of the way here. If RQ equals 4x minus 2, so R to Q, and Q to V is 7, again, my thinking is, all right, this is 1/3 and this is 2/3. So if 1/3 is 7, I can go 1/3 times 2 and get 2/3. So I'm going to take what I got for my 1/3 section, my smaller section, which was 7. I'm going to multiply it by 2 so that it equals 2/3. And then I'm going to set it equal to this to solve for x. So I'm going to say 14 equals 4x minus 2. Add 2. 16 equals 4x. Divide by 4. Therefore, x equals 4. So we were able to solve both of those questions by, again, taking what we know, applying the median and centroid properties, and then figuring out what we don't know.